In this video, we'll talk about taking the derivatives of these sine and cosine functions. So we've talked about a bunch of different types of derivatives so far. We talked about polynomials, exponential functions, linear combinations, products, quotients, all these things we discussed. One thing we haven't talked about yet are trig functions. And so we're going to talk now about how we can differentiate these trig functions. And the results we get from all of this are the following. If I differentiate the sine function, I get cosine. And I differentiate the cosine, I get negative sine. And now that we have these, we can combine these with our other rules from before to differentiate more complicated functions. So we can do things like product rule, quotient rule, all that stuff with these functions as well. And so now we have a whole bunch more functions we can now take the derivative of. So why are these derivatives what they are? Well, we're going to go from the definition, and the main sticking point is going to be our special trig limits from earlier. Let's see how this works out. So let's take the sine function, and let's compute the derivative from the definition. So f prime of x should be the limit as h goes to 0, f of x plus h minus f of x all over h. I can then plug in my f of x, which is sine of x. Limit h goes to 0, sine of x plus h minus sine of x all over h. Now I want to use our sum formulas for sine to simplify out this term right here. So we know that sine of a plus b, by our formulas from normal trig stuff, is sine of a cosine of b plus cosine of a sine of b. And so we can plug that in here. That makes this become the limit as h goes to 0, sine of x cosine of h plus cosine of x sine of h, and then still minus sine of x over h. Now I'm going to regroup the numerator based on what function of x they have. So I see two copies of sine of x. I'll group those together, and I'll leave the cosine x as a separate term. So this then becomes, I have sine of x times a cosine of h minus 1 plus a cosine of x times a sine of h all over h. Now I want to split this limit into two parts over that plus sign in the numerator. So that's going to become the limit as h goes to 0 of the first part, sine of x times cosine of h minus 1 over h, and plus a limit as h goes to 0, cosine of x times a sine of h over h. Now what happens here as h goes to 0? Well, as h goes to 0, sine of x doesn't change. So sine of x just becomes sine of x. No big deal there. What happens to this limit here as h goes to 0? Well, that's one of our special trig limits. We know that that goes to 0. 1 minus cosine h over h, or cosine of h minus 1 over h as h goes to 0, this goes to 0. Plus our second set of terms, we have this cosine of x. That does not depend on h, so that's going to go to cosine of x, no big deal. And limit as h goes to 0 of sine of h over h, that's our other trig limit, that goes to 1. Simplifying all of this out, I have a sine of x times 0 plus a cosine of x times 1. This equals cosine of x. That's how we get that this derivative should be cosine from the definition. The same process works for taking the derivative of cosine, but for that one you're going to need the other identity. Cosine of a plus b is cosine of a cosine of b minus sine of a sine of b. And the same trig limits will apply to give you that that derivative should be minus sine of x. Now we can now just apply this stuff to a problem. Now that we know the formula for what we get for the derivative of sine or cosine, we can just use any of our other rules to get more complicated functions. I'll take the derivative of cosine of x over x squared plus 4. This is just done by the quotient rule. So my derivative should be x squared plus 4 times the derivative of cosine minus cosine times the derivative of x squared plus 4 all over x squared plus 4 squared by the quotient rule. And now we can take those derivatives. So I know I get the x squared plus 4 up top here. Derivative of cosine is minus sine. Then minus cosine of x times the derivative of x squared plus 4, which is 2x, all over x squared plus 4, quantity squared. That's what you would get for the derivative there. So that is the idea of how you find the derivative of sine and cosine, how you use these trig limits from before to get these answers, and then how you use these formulas to then find the derivative of more complicated functions that involve sine and cosine.